Hello, this is Team 10 and this will be our project Univisit. So I will give you a demo of how a project works. So basically this is the home page and it has home Sparkle endpoint. This is a custom Sparkle endpoint where semantic users can enter their own queries and query our data model. From source code you can find a source code about. So this is a home page. Let's start to search. So we can search by many factors. We can search by city. So in city, if we give a city name, all the universities in that city will be listed. For example, Phoenix, and this gives all the university in Phoenix. Okay, so let's go back. Similarly, we can search by state. Here in our data model, we have used 3 states, Arizona, Washington and California. So let's search for California. We have to give state codes in this. So you can see all the universities in that state. You can also search by all the universities nearby a university. For example, I search Arizona State University and I want to know all the universities nearby this university. So these are all the universities in the vicinity of this university. For example, you can see Brooklyn College, Phoenix. So it has given more or near all the Phoenix and Arizona universities. This is done basically by using latitude and longitude. So this query demonstrates the main purpose of our project. So if you search for a college, you will know all the statistics about the weather, restaurant, crime data, the college information, etc. So let's search, like for example, American Institute of Technology. So in this page, you can see all the contact details about American Institute of Technology, like phone, fax, website, address, head of university. Here you can see the crime details about that university, that what is the crime like. For example, on-campus crime is 0, crime reports is 3, resident hall crime is like 3, etc. Here you can see the weather information where this university is located. The average temperature is 300 Kelvin, maximum temperature is 302 Kelvin, like that. You can also see the restaurants nearby this university, their rating, reviews and phone number. Here you can also see the recent Twitter post about this university. Okay, so let's go back. Now you can also uh, search by specific data sets. For example, you want to get only the weather information. So let's go to the weather information. Here you have many options. So for example, if you want universities with humidity less than a certain value. For example, if you want universities less than humidity 20. So let's go to get university. And here we can get all the university and the branch names where humidity is less than 20. Similarly, if you want universities within a certain temperature, so the temperature is in Kelvin, so if we get 290 and for example 300 and do get university, it will show all the universities within this temperature range. Okay, so if you want universities below a certain temperature, for example 290, we can get all the universities below that temperature range. Okay, and if you want universities above a specific temperature range, for example 295, we can get all the universities which have temperature more than that value. So now let's go back to the home page, and we just saw the weather stats. If you want to search restaurants near your university, we can simply give university name, for example Arizona State University, This name actually has to match what is in the database. And if you search for Arizona State University, we'll get top best 5 restaurants and their rating and review and the phone number. Okay, so let's go back to the home page and see the crime queries. So in crime queries, we have certain queries that if the user wants to know which university has the highest public property crime, or has the highest resident hall crime, or has the highest on campus crime. So if the user just clicks on these buttons, it will query the database and RDFs, and you will get to know about those universities. Similarly, if the user wants to know the safest universities to go to in case of residence hall crime. So let's see this. So these are the universities which has the least residence hall crime. Similarly, you can also use a Sparkle endpoint. You can give a custom Sparkle query and query our database. So for example, I have a Sparkle query already, and if I give this, if I give this Sparkle query, I will, for example, I take this Sparkle query and so this queries my database and results. This is a feature we implemented for our semantic users who wants to play around with our RDF data. Similarly, you can get all the information about the scraper. You can download the scraper from our website. You can get the project report from our website, and the about tells about that why are we different, why is our vision different, what is the target audience, and about the team. Similarly, in the end of this page, home page, you can go to the Sparkle endpoint page. You can get the source code of our application, and if the users are more interested in learning about semantic application, they can just go and it will be directed. It will tell the user more about the semantic knowledge. So now I will give you an overview about the source code structure of this project. So we have used Java servlets and Apache Jena framework to develop our project. So in the web content, you can see the various JSP and HTML pages, which are the front end. So whenever any action happens, this is tied back to the backend using web.xml. So which backend class should be called, and the main backend class is home.java. Home.java is like the controller. So whenever a form is submitted in front end, home.java checks which form is submitted, checks the option which are submitted, for example radio buttons, and decides which query to call. All the queries are basically in query-data.java. In query-data.java, we have created 4 models for university, crime, restaurant, and weather. We did not create one single model because we tried that approach earlier, but we had too many RDF triples in lakhs, and the time to query that model was taking a lot of time. So therefore we decided that even if we had queries which wanted to query more than one model, we'll give an input, we'll query a model, take the output. Using that output, we'll again query another model, so that way it was faster. So for example, let's see one query. Okay, so let's see this restaurant query. Okay, so in restaurant, or let's see the weather query. So in weather query, for example, a string is passed. This query is stored in query string. This query is then executed. And the results are in results. In results, we take out the values which we want to display by using the variables, and this is a variable. Now we add all of these variables in a list. Rest details is a list, and then we put this list in a map. Then we send this map to front end, from where it is extracted again and show to the front end. We hope you liked this project. We had a lot of fun throughout the semester in developing this, and let us know in case of any questions. Thank you.